Hello and welcome to the channel Chemical Engineer. I am Sahil Yadav and we are doing the quick revision course for GATE 2022 for the subject Plant Design and Economics. So this is a part 2 video. Part 1 we have covered about various methods for cost estimation, cost indices, profit loss, interest, depreciation, and then we covered about rate of return and payback methods. All right, so please, if you haven't watched the part 1, please watch it first. Okay. Okay, so in part 2 we are going to design of a vessel under internal pressure. Okay, so we will see the formulas. These formulas are important because GATE always asks one question based on the formulas which I will cover in this video. It may be given if suppose the formula is different from the one which I show you here. If suppose the formula is not learnt during your course of plant design and economics, then GATE will give that formula directly. But mostly whatever formulas that I will cover in this video will not be given. Okay, so design of a vessel under internal pressure. So here we have a different formula for the determination of the thickness of a vessel for different shapes. Okay, so suppose first case is the cylindrical shell. So if a vessel is cylindrical, then the minimum thickness of the shell, okay, so this is for the shell of the cylindrical shape. So thickness of that shell should be given as P into di divided by 200 Fj minus capital P again. Okay, so you have to remember this formula, which is equal to P d naught divided by 200 Fj plus P, and the answer that you will get is in mm. So let us discuss what all these units are. Okay, so for cylindrical cell you have to use this formula where P is the design pressure. So if design pressure is given, directly use it, otherwise they will give you a operating pressure. So design pressure is 1.1 times operating pressure. Please note it down all the things which I am writing on this whiteboard. The unit of pressure should be kgf per centimeter square. If any other unit is given, please convert it into kgf per centimeter square or bar. Okay, di is the internal diameter, d naught is the outer diameter, so those are the diameters of shell, inner or outer. Di means inner, do means outer, both are in mm. F is known as allowable stress. The unit is kgf per millimeter square. Okay, if any other unit is given, please convert it into this unit. And J is the joint factor. So joint factor mostly will be given, and if not given, please take 0.65. Okay, so these are all the things, and then after putting all these things you will get the thickness of the shell. So this was for the cylindrical. Second is for the spherical shell. Okay, so for spherical shell, thickness is given as PDI divided by 400 Fj minus P. Please note down the formula. This also will give you in mm. Okay, so in order to design a vessel, we require a shell, then we require head and closure. Like suppose this is the main area where the reaction will take place, so this is made up of shell. Now shell are generally having heads on both the ends and closures as well. Okay, so those heads and closures are generally of different shapes. So let me write head and closures. So head and closure. So first type of head that we will have to learn is the flat head, or we can say flat ends. So for flat ends, minimum thickness formula is CPD under root P by F. Okay, you have to remember this formula. Cp is constant, D is a nominal. Okay, so D is nominal plate diameter. You have to remember how to calculate nominal plate diameter if not given. P is the design pressure and F is the allowable stress. Cp is the constant which will be given to you. Okay. Second type of head is hemispherical head. Hemispherical head. Okay, so if hemispherical head is used, so generally it is having the same formula as of the ellipsoidal head. Okay, so let us see ellipsoidal first. Ellipsoidal head. So what is the characteristic of ellipsoid or ellipse? Is major to minor axis having the ratio of 2:1. So the thickness, minimum thickness required for that head is PDI divided by 2FJ minus 0.2 P. Okay, so this is for ellipsoidal head. So you have to remember this formula as well. And the fourth important formula is Tori spherical head. Okay, so Tori spherical head, how these heads will look like, please I will share the one photo on Telegram group, so please join there and you can see that photo, how all heads, different types of heads look like. So here we have to RCCS into divided by 2FJ plus P into CS minus 0.2. Okay, so CS is known as stress concentration factor. Okay, so this is known as stress concentration factor, and in order to calculate this stress concentration factor, so how to calculate stress concentration factor? So we have a formula CS equal to 1 by 4 into 3 plus under root RC by RK. RC is the crown diameter, RK is the knuckle diameter. Generally the value of RC by RK is less than 1, but it's 0.06 greater than 0.06. If not given, then take 0.06. Okay, so these all are the formulas for uh, different types of heads. Moreover, we have a conical head as well. So this is the fifth number, conical head. So conical heads are generally used as a reducers. So this head is having the formula of minimum thickness as PDI divided by 2FJ minus P into 1 by cos of alpha. Because these head are conical. Conicals are generally having some angle as in the triangle. So they are having the angle. So suppose this is a cone. Okay. So the angle you have to take is half of the angle. So this value will be alpha. Okay. Half only from the center. So this is how you can calculate the value for thickness of minimum thickness of different types of heads and different types of shells. Now let us see a criteria of selection for Pact tower. Okay, so Pact tower are generally used in distillation as well as in absorption. Second, why we should choose Pact tower is cheaper than tray tower, when tower diameter is less. Okay. Third, uh, for corrosive system we use Pact tower. Okay, so whenever there is a corrosive system, then plastic Pact tower with plastic packing are generally used, because they will be cheaper to repair or to exchange. Fourth advantage is provides higher mass transfer rate. Okay, provide higher mass transfer rate due to higher area of contact. Higher area of contact. Moreover, this Pact tower are used for high foaming and heat sensitive liquids. So when we want to work with heat sensitive liquid as well as high foaming system, we'll use Pact tower. Okay, so these are all the uses of Pact tower. Moreover, pressure drop is also less. So these all are the important things you should remember for plant design and economics. We are left with one topic, that is the designing of shell and tube heat exchanger. That designing we will cover in the playlist of heat exchanger, all about heat exchanger. So thank you for watching, and please subscribe to the channel, and please share this video as much as possible. Alright, thank you. Please join Telegram as well. Alright, thank you.